Hello everyone, my name is Hafiz and I am delighted to share our internship experience with you today. Over the course of next 15 to 20 minutes, we will take you on a journey through the fascinating world of embedded system and microcontrollers and how we applied this knowledge to design a microwave oven. So first of all, I want to express my sincere gratitude to Emetxe for providing an invaluable internship opportunity. It has been an enriching experience, and I am truly appreciative of the chance to learn and grow within this esteemed organization. Before we dive deeper into our internship experience, I would like to introduce you to two invaluable individuals who were part of this journey with me. Here we have Sinchana and Meghana, both of whom have been instrumental in our collective progress. Moving on, I am pleased to introduce Sinchana, who will now take the floor to share our experience from the first part of our internship.
Thank you, Hafiz, for the introduction. Hello, everyone. I am excited to share with you the highlights of the initial phase of our internship journey. Over the next 6 to 7 minutes, I will walk you through some of the key experience and lessons we have gathered. In the initial phase of our internship journey, we delved into several fundamental topics that laid the groundwork for our exploration of embedded systems and microcontrollers. These topics included an introduction to embedded systems, a deep dive into the C programming language. Our journey began with the comprehensive understanding of embedded systems. We learned that embedded systems are specialized computing systems designed to perform specific tasks, often found in everyday devices like microwaves, washing machine, and even cars. These systems are at the heart of modern technology, enabling automation and enhancing functionality in various industries. One of the most lightning aspects of this phase was discovering the real world applications of embedded systems. We realized that these systems play an important role in improving our lives. To gain a deeper understanding, we divided into the components of embedded systems. We explored the core elements, including the central processing unit, random access memory, and read only memory or flash memory. These components work in tandem to execute tasks efficiently and store critical information. The next milestone in our learning journey was immersing ourselves in the basics of C programming. We discovered that C is the language of choice for programming microcontrollers. As a part of our journey into embedded system, we recognize the importance of having the right tools at our disposal. One of our initial steps was to install the necessary software to facilitate our practical learning. First, let's talk about PixSimLab. This software proved to be an accurate simulation tool for us. It allowed us to create a virtual environment where we could test and debug our embedded system projects before deploying them to a real world. Next, we tackled the installation of MPLab XID. This integrated development environment serves as a central hub for our coding and debugging efforts. It provided us with a cohesive platform for writing, compiling, and managing our code. Finally, we installed the X8 compiler, an essential component in the toolchain. This compiler is specifically designed for the PIC microcontroller family, making it an optimal choice for our embedded system project. With X8 compiler in our toolkit, we gain the capability to transform our code into executable programs that can run on microcontroller hardware. Moving further, our exploration of memory segments and the preprocessor in C programming expanded our horizons. Memory segments, including stack and heap, are crucial for efficient memory management in the embedded system. Understanding text space allowed us to optimize code, making it more efficient and conserving precious memory resources. Next, we explored the stack. Learning about the stack helped us to write structured and organized code, ensuring that our microcontroller's memory usage remains efficient. In summary, our exploration of text space, stack, data segment, and heap has provided us with comprehensive understanding of memory management in embedded systems. These areas are the foundation upon which we build efficient and effective embedded systems applications, and we look forward to applying this knowledge in our upcoming projects. Without further ado, I would like to invite Meghana to the virtual podium as she takes us through the exciting next phase of our internship journey.
Thank you, Sinchana, for the kind introduction. Hello everyone. I am excited to share with you the highlights of the initial phase of our internship journey. Over the next 6 to 7 minutes, I will walk you through some of the key experiences and lessons we have gathered. During this phase, our focus shifted towards practical application and project development, and we explored a range of fascinating topics. Let's start with an overview of the microwave oven project and then delve into the specifics. The centerpiece of this phase was undoubtedly our microwave oven project. Building on our foundational knowledge, we embarked on this project to implement the concept we had learned in a real world application. The microwave oven is a household staple, and understanding its internal working was both enlightening and challenging. We tackled this project with enthu- we tackled this project with enthusiasm, breaking down its complexities step by step. One of the key elements that enabled us to bring our microwave oven project to life was our grasp of basics of microcontroller. We learned about microcontroller architecture, its components, and how it interacts with other parts of the microwave, such as the display, keypad, and heating element. Next, we explored schematics, where we got to know how each components are connected to the ports of the microcontroller, such as keyboard interfacing, CLCD interfacing, etc. And also mainly we learned how we need to access the ports by triggering the tri-state bits. And also we learned how to translate our designs ideas into schematics, ensuring that all components were connected correctly. To streamline our project development process, we utilized a template. Templates provided a structured starting point, saving us time and effort in creating code and schematics for the similar components in our project. This organizational approach allowed us to work more efficiently. Our microwave oven's interface was a key focus, and we learned how to incorporate tactile switches and matrix keyboards. These components enabled users to interact with the microwave by pressing buttons and selecting settings. We learned how to read input from the keypad, decode button presses, and translate them into a meaningful actions in our microwave oven project. This knowledge was essential for enabling users to input settings and commands with ease. We learned how to read input from the keypad, decode button presses, and translate them into a meaningful actions in our microwave oven project. This knowledge was essential for enabling users to input settings and commands with ease. In our microwave oven project, tactile switches were strategically placed to control various functions like power, timer setting, and cooking modes. We learned how to connect and program these switches to respond to user input accurately. We gained a basic understanding of how tactile switches work, including their electrical characteristics and the need for debouncing. We encountered an important concept in the second phase of our internship, the debouncing effect in switches. When a switch is pressed or released, it can produce rapid electrical fluctuations, causing multiple unintended readings. We learned some of the methods to implement debouncing effectively, ensuring the reliability and accuracy of the user inputs in our microwave oven project. Another concept covered was interrupt and interrupt. where we will got to know what is an interrupt and how we can handle the interrupt through the interrupt service routine, and some of the procedures to place the address in the program counter. And also we learned a term called GIE, that means global interrupt enable bit, which maintain the enabling and disabling the interrupt. Another critical aspect of our project was the use of timers. Timers allowed us to preciously control timing and delay in our microwave oven operation. This was especially important for tasks like heating food for a specific duration. In this session, we learned about timers which should be used to maintain a proper timing, and some of the major terms like resolution, tick, and quantum scaling. And also we get some what idea about the timer 0 module from the data sheet. Finally, we explored CLCD or characters LCDs, which were essential for displaying information to the user. Learning how to interface with CLCDs allowed us to provide a clear feedback and status updates to the microwave's user interface. Now, as we move forward in our journey, I am delighted to hand over the virtual podium to Hafiz, who will delve into the simulation part of our project.
Thank you, Meghana. So finally, we will take you to the project guided by Rajini ma'am. Let's take a closer look at how simulation has enhanced our understanding and skills in embedded system. As we step into the simulation part of our presentation, one of the first element we encounter is the power on screen that greets user with the reassuring message, powering on microwave oven. This visual cue signifies the initiation of our appliance and sets the stage for user interaction with our virtual microwave oven. Upon powering on the virtual microwave oven, we are welcomed by the menu screen, which presents users with the 4 distinct modes: micro mode, grill mode, convection mode, and start mode. These modes offer a range of cooking options, allowing user to customize their cooking experience based on their preference and needs. As we navigate through the menu screen and select the micro mode by pressing 1, initially it displays the current power consumption in the system, that is 900 watt, which is predefined in the program, giving us insight into the energy usage. Following this, the display prompts us to enter the desired cooking time in minutes and seconds, allowing for precise control over the cooking process. As we set cooking time into the micro mode, the virtual microwave oven springs into action. The display begins counting down the time, showing us the second and minutes remaining for our selected cooking duration. Simultaneously, the system triggers the fan, simulating the cooking process. As the countdown reaches to 0, signifying the end of the cooking cycle, the fan operation ceases, buzzer triggers, and display return to familiar menu screen. Similarly, the grill mode also perform in a similar manner. It will initially ask the timing, so you need to enter the required timing, and if you want to clear the screen, then you need to select the clear option. Otherwise, you can proceed with the enter option. So similar operation will be performed by the system, same as the micro mode operated. So in the convection mode of our simulation, the virtual microwave oven prompts us to set the desired cooking temperature, allowing for precise temperature control. After setting the temperature, it will initiates a preheating phase lasting approximately 18 seconds. This step is crucial for ensuring that oven reaches the desired temperature before cooking, replicating the preheating process familiar to convection cooking. Once the preheating is complete, The simulation follows a similar pattern to the micro mode and a grill mode. It requests us to input the cooking time in minutes and seconds, providing us with the flexibility to fine tune our cooking process. So, when we select the start mode, it defaults to a 30-second cooking duration, providing a rapid solution for heating or cooking. Additionally, the simulation allows us to increase the cooking time in a 30 seconds increment simply by pressing a start option. So that is fourth option, offering a hassle-free way to extend the cooking duration to meet our needs. As we bring our simulation presentation to a close, we extend our heartfelt gratitude to Emetxe Information Technology for providing us with this invaluable opportunity to explore, learn, and apply our knowledge in this realm of embedded system. Thank you for this invaluable experience.